Today, we're going to be talking about low impact development, and as I'm listening to the introduction and I listen to some of the things that was explained to Don, you hear low impact development, you hear green infrastructure, you hear sustainable development. It's a lot of pieces of the same puzzle. You're going to be hearing today, though, low impact development is exactly that. Those three words are what they mean. It's developing, building our houses and our roads and the things we use to get around and live in, things we need, obviously, without having a negative impact on the environment. That's what this is about. And the term was developed in or expressed in a document that was done in the late 90s by a guy named Larry Kaufman. Did most of the work on this in Prince George's County, Maryland. And there's two definitions I want to take out of that document that really describe the process in a comprehensive way. You're going to be hearing a lot of things today from Don and I, but these things really describe it pretty succinctly. And it's that low impact development approach combines hydrologically functional site design with pollution prevention measures to compensate for land development impacts on hydrology and water quality. It's a mouthful, but the thing is, we're focusing on the hydrology of a site and the hydrologic response from the things we do there, and the pollutants that are generated off the site that are carried into water when it rains. And those are the things we're trying to deal with. The other part of that is the primary goal of low impact development methods is to mimic the pre-development site hydrology by using site design techniques that store, infiltrate, evaporate, and detain runoff. This is really the key. We're going to be focusing on hydrology in low impact development and how to maintain the natural hydrologic response of a site, generally at the site level. I noticed in my slides, I don't, somehow over the years I have lost the word site design. It's really focused on the site level. There are some things that can be done on a broader, somewhat regional basis, but mostly at the site. So the objectives today are going to be to understand the principles of low impact development, discuss the hydrologic considerations, explain the principles of LID site planning, discuss the incorporation of LID and green infrastructure into watershed and community master plans. And a lot of these, this is where it really starts getting synonymous. LID and green infrastructure techniques are often the same thing, just the application or the thought process might be a little different, how you're using them in any particular situation. And understand LID and structural BMPs. Don's going to go through that in great detail this afternoon. A lot of the design for the practices that are used as part of low impact development, but we're also going to be talking about the site planning aspect. You can get away without using any BMPs often if you do good site planning. Understand and discuss the economics of LID. That's the bottom line, right? That's what everybody always asks. How much is this going to cost me to implement? What's in it for me? Why would I implement this stuff if it's going to cost me a lot of extra money when I've been doing it another way? We'll have some discussion about that. If at any time you have a question, raise your hand. You can stop me at any time, or you can keep until the end. We'll have spots for the questions after the end of each section. So feel free to interact. It's a nice, comfy group, and you've already got a question. That's good.
Well, your fourth point there in regards to incorporating master plans and things of that sort, that's all fine, but it really comes back to, what you mean by the economics of it. It's not just incorporated into a master plan, it's incorporated into local regulations.
Yep, and you'll hear a little bit about that.
Because, in regards to this stuff, that's the point. What's in it for me?
That's right.
What's in it for you is you have to comply with an ordinance.
Right.
Well, so actually we can adjust that real quickly. Ralph's right, there's going to be more of that coming later.
Yeah.
When you think about it, there's a carrot and a stick approach, right?
Yes.
What you're referring to is the stick approach. I have to do it because the regulations say I have to do it. We're actually trying to get away from that. Right? We're actually trying to show, look, there's also a carrot approach. There's incentives beyond the DEQ or the county or somebody telling you you must do it. And so what we're trying to do is say, look, there's incentives for people to do this beyond regulation. Okay, and if we can get that message across, that's more than half the battle. We want people to do this not because they have to, because of the broader picture benefits that exist. And so we're going to touch on both of those.
So that's what we were all just talking about is what this is all about, correct? We build roads, sidewalks, houses, rooftops, parking, mostly hard surfaces where there used to be vegetation. We'd probably level this land. We're going to be talking about that. We changed the topography. We completely changed the natural runoff characteristics. And in the process, we should expect. We didn't expect, but we should have expected that the natural systems, the river systems, the lakes, all of our water, even the groundwater supply, would respond. Right? We've changed the way this all works without really thinking. We ship the water off usually in pipes over to the river systems, and then maybe got surprised when, why is this so bad? Why has things changed? Just before the low impact development document that I showed you came out, this chart came out that I used over and over again. A lot of people use it. Came out of Washington State. There was a study of riparian and biotic integrity as a function of watershed urbanization. And it really shouldn't surprise anyone, but it was a great document that we all depended on for a long time that basically gave some justification, some scientific credence that yes, as urbanization goes up, water quality goes down. And the farther you go, it gets pretty bad. It goes from good to fair to poor based on the parameters that we were measuring. Since this has happened, people have done numerous other studies that have shown various other impacts of based on habitat degradation or particular species loss that says the same thing, all based on urbanization. And it starts with about 10%. Once you hit 10% development, the watershed begins to deteriorate. And by the time you hit 30 or 40%, you're down into degraded. You can see this in even more. This is one of Don's slides that you go from pristine to impacted to down greater than 65%. Well, you might as well just pave it. The effects that happen around here on both pollutant accumulation in the watershed there, and the destruction, what happens to the rivers, and I'm going to be going through this in one of the presentations later, is immense if it's uncontrolled. We can still do this, but we need to do it in a way that doesn't cause this impact. So what happens? What's the mechanism? Well, if before there was any building, the mechanism with the hydrology of a site is essentially a very little bit of runoff, 10%, a lot of infiltration, and evapotranspiration. Vegetation is huge. I cannot stress throughout the day the need for vegetation. And once you incorporate it into development, it's a strategic placement and use, but it's still essential in order to be successful doing applying lid. So as you move up with just a 10 to 20% impervious surface, you can see you start to have effect. You've already doubled the runoff from what it was before. And ultimately, if you go to 75% to 100% impervious surface downtown Detroit, maybe even downtown Traverse City, you have now increased the runoff by 45%. And that's the biggest focus that I normally do in most of the work that I do is try to deal with this. It's the most visual impact to streams, but we also are at the same time trying to improve and enhance groundwater supplies and other effects. So, but that runoff number is the number that I focus on most. Okay? This is a site, what happens on a site, and the difference in development. So in before development, without any numbers, the flow, this Q is the flow, T is the time. You have a gradual rise in the runoff and a gradual decline over time. As you pave, that gets greater. That rises. It rises fast and it comes down fast. Okay. Flashings. A lot of people refer to that as flashings. Same thing happens in the river then. So what you see in the river, and we'll talk about this in even more detail in the hydrology talk, is a quick spike, and for the undeveloped, you have a very, very gradual flow change, over time from after an event. In high development, you've got a quick spike and very high, so that it's hammering the stream channel, causing a lot of erosion. Under the best of circumstances, unless you're in a mountain stream, it can't respond to that kind of impact, and responds with erosion and tries to adapt it and what it can. What we're trying to do is we are going to try to get as close to this as we can through the implementation of LID. That's really what it's all about. Okay, by adjusting that site hydrograph that you saw in the previous slide. Okay, some of the pollutants that are picked up along the way. What happens also is all the things we put on the parking lot, all the things that accumulate on our roof from dust, all the things we use, we put on our land, fertilizers and pesticides are also all picked up by the stormwater flows, the rain, and carried off in all the systems we've now created to efficiently take that water away, puts it right into the natural water ways that we have. So suspended sediment both comes from runoff from a number of things, any open construction sites, agriculture, deposits from cars, picking up dirt and stuff from cars that comes off on parking lots, all that, as well as what happens to the stream if you cause erosion by exacerbating flows, by increasing flows. So suspended sediment is a huge one because it comes from a lot of places. Nutrients can be added from the content of the suspended sediment you've just created, but also probably what most of us think about is fertilizer use and how they're applied. Same thing with pesticides and herbicides. Heavy metals come from car parts, brakes. As your brakes wear and tear, the dust off of them has heavy metals in it. The rusting of your car, anything that comes off of that. Those get again picked up on a parking lot. Sometimes the dust, depending on what's being produced in the industry around a particular area, the dust that falls from those smokestacks may have different kinds of metals in it. Coal, the one thing that isn't really handled by that, goes beyond lead, is mercury in coal. The exhaust from coal-fired power plants is huge. It's one of the big sources of mercury in the state, or in the nation. Hydrocarbons, oils, gasoline, grease, anything that drips off of your car. So, a simple BMP is just good car maintenance, just to reduce that. Bacteria, pathogens, everything from, you probably have all seen somewhere, I gotta believe, because it's everywhere now, a doggy doo-doo station, you know, so that we're stopping the, you know, at least properly disposing of pet waste, but different kinds of techniques for wildlife. You know, a lot of wildlife will be attracted, raccoons and things will sometimes get into sewers, and if they're living there, they're concentrating their waste in there, right? So there's a lot of ways to pick that up, but also for us, septic systems, and you know, improper management of septic systems, and those kinds of things, or ultimately even you know, poorly maintained or you know, not properly connected sewer discharges. So, and then trash and floatables is everywhere. And if any of you read it, it blows my mind sometimes when I look at what's happening in the ocean. If you see the amount of these floating islands of plastics, just that's blowing away from everything that we're using, and it blows out into the ocean. And then salt, which is a tough one to deal with. Salt is a dissolved substance. You know, once it dissolves into stormwater, it's very hard to remove. So really, the B&P here often is find an alternative, different road design, different materials to do de-icing for safety. These were all called Nonpoint Source pollution. It's usually a diffuse source. If you live south of Clare, a lot of the places there now, this is point source pollution, only by definition. The mechanisms are all the same, but there's stormwater permitting in areas that hasn't quite reached here yet. The population hasn't reached the regulatory threshold to cause a stormwater permit to be implemented, but a lot of the techniques that we're going to be telling you, both for the hydrology and for the pollutant removal stuff, is being required in many communities south of Clare. So, why? You know, what's the root cause of doing all this? Well, our construction techniques and the way we do things today, the very first thing we often do in a site is clear it, level it, take away the natural topography. And we replace it with a lot of very dense rooftops, driveways, sidewalks, and roads. Or, gotta hit the right button, or just pave the whole thing. Take away everything and put in a mall, parking, office space, whatever it is, football stadium, and take away all those all the vegetation, all the access to the soils, and then provide mechanisms to take all that water away, completely changing the natural way of drainage. So we set up extensive stormwater systems with catch basins and pipes all along the road, curb and gutter, collecting every drop of water that comes off of our roadways and channeling it into pipes to quickly carry the water as fast as possible into the nearest waterway. We have to change all this. The concepts of low impact development are to do this in a way that emulates the natural way that this used to occur. Oh, I forgot. The biggie. Detention ponds. Detention ponds, I don't know, probably in the 70s, well, even before that, detention ponds were used to mitigate flooding, primarily higher flows to help take away those impacts. When we started realizing that there were some environmental impacts and what we were doing to rivers, we started modifying the design criteria for lower flows to help take off that peak I showed you on that hydrograph. And it was effective at that, but I'll show you in the hydrology discussion in a bit that that's not the only, the rate was not the only issue. So we built these things, and or we modified these things to help address that, and we actually, in some cases, made the problem worse for a number of reasons, and we'll talk about that. Not that they don't have a place now, but the design criteria needs to be consistent with redeveloping that pre-development hydrology. So, we've been saying it over and over again. LID is the practice of minimizing environmental impact and creating a stormwater plan that mimics the pre-development hydrology. What you're going to be hearing from here on out is how we address hydrology, and at the same time are able to take out those pollutants I pointed out while we're doing so. But it's focusing on hydrology. Conservation, site design, sustainable site design, green infrastructure, we're throwing out all those words. But some of these things, if you can address so much in the site design process that you may not have to put in some elaborate BMP. If you work with the natural topography, maintain green space, take advantage of the soils that you can infiltrate, use it for infiltration, that might be all you do. It might be a design issue. But then, if it's not, then we'll get into non-structural and structural BMPs. Don's going to go through that this afternoon. And then reduction, infiltration, extended detention, and reuse of stormwater. And I have to say that most people really focus on infiltration, and that's good because when we talk hydrology, we want to enhance groundwater that we've removed by not letting it soak into the ground. And an easy way to do that is to just maximize your infiltration practices. But we shouldn't neglect evapotranspiration and reuse. Evapotranspiration by a tree, when you think about it, a large tree with a canopy, if you look at what the surface area of the leaves on that thing add up to, it could be a couple football fields. And if water hits that, it evaporates, never hits the ground. When you walk in a forest in a rainstorm, in a gentle rain, you don't get wet. Until it gets heavy enough to do that. So we'll be talking about that. And then reuse also. Lots of mechanisms for reuse of water. Don't let it run off. Use it for toilets or irrigation or many other things. Okay, the principles of LID. Very quickly. We'll go through all this in more detail. Plan first. Step back, take a look at your site and what you have, and come up with a good plan for implementing. Prevent, then mitigate. It's always easier to prevent an effect than to try to go back and mitigate or redevelop. Minimize the disturbance that you cause. Protect the green space that you have to the extent that you can. Keep the trees, keep the large trees. Even if you plant trees as part of your plan, those are going to be, it's going to take a long time for them to mature. A mature tree both soaks up hundreds of gallons of water and evapotranspirates, intercepts water from the rain. Manage stormwater as a resource. Irrigation, aesthetics. People have used this for fountains and ponds. Think of it as a resource, not a waste that has to be gotten away off your property as fast as possible. Mimic the natural water cycle, and that we're going to be explaining over time. Disconnect, decentralize, distribute. Downspouts should not go directly to the curb and gutter. Disconnect downspouts from the curb and gutter. Put them out on the lawn or carry them away to other green space. Decentralize. This is the key word. Most of this practice is at the site level. You want to work on the site level. That's the most effective and the most cost efficient. Integrate natural systems. Maximize the multiple benefits. We'll go through those. We're talking about the environmental benefits for the most part right now, and what happens. But there's a number of other benefits to LID. I'll go through some of those in a minute. Use LID everywhere. There's no place you couldn't apply a LID practice. and make maintenance a priority. I say this about anything. When I'm designing a sewer, when I'm doing other things, maintenance is often neglected. If you think about whatever you think about the current road funding plan, that's coming up here for a vote, a lot of what got us into that is not maintaining the roads. So maintenance is essential on anything you put in. Okay, so just quickly, our conventional site design, I've already showed you a picture of how we maximize, we completely level and rebuild our site in a typical site design with connected roads, a storm sewer system, maybe a detention area, a more low impact development design would be maintaining our green space and our natural areas, building in ways that maintain connected green space. Our drainage system are swales, not pipes. We use rain gardens to absorb the excess on any individual site, or maybe a couple of individual sites at a time. The detention is now a wetland that's used as polishing and an attribute for the community. There was in Ingham County long ago, the drain commissioner was faced with moving stormwater off of a site that would cost millions of dollars to get to the Grand River from where they were at. Instead, it was right near a golf course. He piped it into a wetland, made a constructed wetland, put it through some natural filtration through peat and buffer strips, made it a nice little water feature for the neighborhood, put a walking path around it, uses the water that he detains, the excess water, to water the golf course, and the community loves it. Before it was done, people were walking around the site, using it on their daily walks. It attracts a lot of wildlife. So it was an attribute to the community, and it still was a significant cost, but at least half as much, more than half as much as running that pipe as far as he would have had to run to take care of the same issue. Okay, some of the benefits of LIT. It helps communities meet stormwater standards and regulations. A lot of these are local up here, as opposed to, well, they're all local, but as I said earlier, you don't have the stormwater permitting that happens further south. So these are the regulations that you're deciding for yourself. Promotes smart growth. So you don't have the impact on the resource you have up here as growth continues. Reduces municipal infrastructure costs. Don will go through that in more detail later this afternoon. Provides a cost-effective alternative to traditional development. So you're less land clearing, reduced infrastructure, and Don's going to talk about costs and economics later, and you go back and forth when you put the pieces together. But there's more cost here, and that's this guy's cost as opposed to that guy's cost. And if you put the whole picture together, though, LID costs less. Almost always. There's situations where it doesn't, but almost always. Increase the appearance and aesthetics of community. Use these things as an attribute. Rain gardens look nice. Water features people are attracted to water features. Increase public safety, such as traffic calming from the way the road is designed to provide less runoff. Obviously protects the environment. Human health. Think the water issues water supply issues in Toledo last year. A lot of those were related to agricultural contributions, but our urban pollutants contribute to that as well. Protects groundwater, drinking water supplies through filtration and infiltration. Properly designed practices will take those pollutants out so we don't contaminate our drinking water supplies, and reduces flooding and protects property. It's good for the economy. honest, it is. We'll talk about that. And certainly assist with LEED certification and sustainable sites initiatives. Challenges. Public acceptance. You already started bringing this up. You know, some of the challenges to get this implemented. I put a lot of these in. Change is hard. People resist change. So it is important to educate down here. Keep that in mind as you're going through. Not just regulate, not just say you really should do this, but why you should do this. What's the benefit? What's gonna be the good thing? It's against the status quo. Again, change is hard. Engineers and land development firms need design tools, absolutely. And we have some, more being developed all the time. DEQ has some on their website for the stormwater folks. Don has a ton of criteria. There's a manual that I'm going to show you in a minute that Don and I had the pleasure of helping to develop with SEMCOG, Southeast Michigan Council of Governments. The tools are getting out there, and absolutely they need, and the associations, the engineering associations, the landscapers associations, need to work with each other. You know, locally, you're going to be using different things here because of different geology and rainfall and vegetation than will necessarily be used in Southeast Michigan. You know, those things need to be developed both locally and on a higher scale. Maintenance requirements need to be better understood. One of the problems we ran into in my own community was rain gardens. We put rain gardens in. I said we need to do this for this project we were doing. We didn't do two things. We didn't get anybody to weed the rain gardens, so they became quickly infested with weeds. And we put one of them like darn near right in a field of weeds. You know, so it was infested. It just came in. The planning was poor. And we changed all that. I learned some things. You know, I was having a discussion earlier today. Vegetation is not my thing. You know, I'm the engineer. I can tell you how much water it'll hold, how fast it'll infiltrate, all those kinds of things. I didn't pay close attention to what the vegetative needs were of that, and so those things have to be taken into account. Ordinances need to be rewritten to both allow it and not. You know, the other lesson I had in my own community was that we had a development coming in early on when I was on my planning commission, and I said, well, we shouldn't require curb and gutter there. We should do this. They have the opportunity there. We can use swales here. It's a small thing. It'll work well. Yeah, but our ordinance requires curb and gutter. So we looked at our ordinances after that. This is the manual that I told you about from SEMCOG. It's voluminous, but it's online. I have not put any. I don't know whether Don did or not. I didn't look that closely, but I don't put links anymore because they often change. And today, Google is so wonderful about knowing where everything is on the internet. If you would just Google Low Impact Development Manual for Michigan, it will take you right to this book. So, and the other things that I do over the course of the day. Okay?